What's up, you freaking geniuses? So in this video, I'm going to teach you about the law of cosines and how to solve for triangle lengths and angles using the law of cosines, right? So first, before going into any examples, let's just make sure we understand the three equations, right? The three formulas, which are right up here. And I know they look like a mess, but I'm going to walk you through them, right? So the first one is a squared is equal to b squared plus c squared minus 2bc times the cosine of a, all right? So as you might notice, there's some lowercase letters right here. Now the lowercase a, b, and c stand for the lengths of your sides, all right? So we have a little triangle right here for reference. You can see we have some lowercase letters, right? A, b, and c. So those are the three lengths of your triangle, okay? Now we also have some uppercase letters, right? A, B, and C. So those are the angles of your triangle. So you'll notice on this triangle over here, this is angle A, this is angle B, and this is angle C, all right? And one thing you want to keep in mind is that they're always in pairs, right? So angle A opens up to side A, right? This is side A. So you might notice that we basically have a pair right here, right? Same thing over here, we have angle B, and it opens up to side B down here. So you can see that we have another pair, right? And then lastly, angle C opens up to side C, right? So you can think of these in pairs. Okay, so now that we know what all the variables stand for, let's jump into our example. So here we have triangle A, B, C, and we're given two side lengths, right? This is 11, this is 14, and the angle in between those two side lengths is 34 degrees. So the first thing you want to do before trying to solve anything is just label all your angles and sides, right? So for instance, here, let's start with A, right? So we know this is angle A, so the opposite side over here must be side A, right? So we can label that as A. Now over here we have angle B, so the opposite side over here must be side B, right? And then here we have angle C, so the opposite side where the 14 is means that this is side C. All right, so now that our triangle is completely labeled, now we just need to figure out what we want to solve for. So do we want to solve for one of these angles first, or we can solve for this side? Well, it's completely up to you. So in this case, I'm just going to solve for this side first. All right, so this lowercase b. So I'm going to go to my equations over here and look for which one solves for the lowercase b, or in other words, side b, right? So that would be this one right here. So this is the equation, the formula that we're going to use, right? So we're looking for b squared, which we don't know, right? So we're going to say, first of all, b squared is equal to a squared plus c squared, right? Well, a is 11 and c is 14. So here we're going to have 11 squared plus 14 squared. And then minus 2 times a times c. So again, a is 11 and c is 14. And that's times the cosine of angle B, which is 34 degrees, right? So this is the cosine of 34 degrees, right? So let's just simplify this. So we're going to have b squared is equal to 11 squared plus 14 squared, and that's equal to 317, and then minus all this, right? So minus 2 times 11 times 14. Well, let's just simplify this part first. So that's equal to 308. So we're going to have minus 308 times the cosine of 34. Okay, so then here we're going to get b squared is equal to, now if you just plug this into your calculator right here, you'll get that this is approximately 61.66, okay? Now to solve for b, right, we just need to get rid of the exponent, so we can take the square root of both sides, right? So then these cancel out, and we're just left with b is equal to approximately the square root of 61.66, which is, and I'm just going to round here, 7.9, right? So then here we can label this and say that b is approximately 7.9, right? Cool. So we found, finally, our side length. So we have all three sides, and we have this one angle, right? So the last two things we need to solve for are angle A and angle C. So again, it's up to you whichever one you want to solve for first. And in this case, let's just solve for angle A, right? So which of our three equations uses angle A? Well, it looks like it's this first one up here. Okay, so that means this is the formula that we're going to use now. All right, so let's plug in what we know so far. So we know a squared, right? A is 11, so let's write that up here. So we know that a squared would be 11 squared, and that's equal to b squared plus c squared. So that's going to be 7.9 squared plus 14 squared minus 2bc, so minus 2 times b, which is 7.9, and c is 14, times the cosine of angle A. All right, so let's just evaluate some of this. So 11 squared is 121, and that's equal to 7.9 squared plus 14 squared. So I'm just going to combine these right now and tell you that this is equal to 257.6. And then we're going to subtract 2 times 7.9 times 14, and I'm going to tell you right now that this is equal to 219.8, right? So minus 219.8, and we're multiplying that by the cosine of angle A. All right, so we're trying to solve for this right here, so let's try and get some stuff to the left side. So here we can subtract 257.6, right, from both sides. So then over here, those cancel out. 121 minus 257.6 is equal to negative 136.6. And that's equal to this side over here, what we have left, right? Negative 219.8 times the cosine of A, right? Negative 219.8 times the cosine of angle A. Now to solve for the cosine of angle A, we need to get rid of this guy. So we can just divide both sides by negative 219.8. Divide by negative 219.8. These, let's use a different color. So then these cancel out, and we're simply left with the cosine of angle A is equal to this over here, which is equal to approximately 0.62, right? So we're almost there. Now, the last thing we have to do to solve for the cosine of A is to take the inverse cosine of both sides, right? So on this side, we're going to take the inverse cosine, or arc cosine, right, same thing, of this side of cosine A, and what we do to one side, we do to the other, right? So we have to take the inverse cosine of this other side also, of 0.62. And remember, these are equal to each other, right? So let's get rid of some of this work and move this thing up using math and magic. Boom. All right. Now what happens here, the inverse cosine and the regular cosine cancel each other out. So all we're left with is angle A here, right? So we get that angle A is equal to the inverse cosine of 0.62, which is equal to about 51.6 degrees. All right, cool. So now we know what angle A is, right? 51.6. Now, the last thing we have to do is solve for angle C. But luckily, since we have two of the angles, it's kind of easy to solve for this last one, because remember, whenever you add up all the angles inside of any triangle, they should add up to 180 degrees, right? So 34 degrees plus 51.6 degrees plus this angle should equal 180. So that means angle C should be 94.4 degrees, all right? So now we solved for all three angles and all three sides. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.